Greetings, Year 9, and welcome to our next exciting lesson dealing with straight lines. Today we're going to be talking about the gradient, which is also called slope, and direct proportion. Now, we know that the gradient of the slope is a number that tells us how steep the line is. Remember, if it's a positive number, the line is going up the page. If it's a negative number, the line will be going down the page when we're going from left to right. Now, if the two variables, that means the x and the y numbers, when you compare them, are directly proportional, that means when x gets bigger, y gets bigger at the same rate. You're going to generate a straight line as a fancy way of saying it's directly proportional. And for directly proportional lines, we are always going to pass through the point 0, 0 when we graph it. So when direct proportion exists, the line is always going to be in the form of y equals some number in front of an x. There won't be something like this, y equals 2x plus 3. That won't exist, because if you have the plus 3, it doesn't go through 0, 0. So you'll just have a y and an x part, no number part by itself. M, the number in front of x, is actually the gradient. It's the slope. It tells us how steep the line is. And when we're dealing with proportion, it's also called the constant of proportionality. This is not a topic that we actually spend a lot of time on, this part here. We do spend a lot of time using gradient or slope, but not talking about proportionality. So the gradient, which we sometimes use the letter m instead of writing the word gradient, m is another way of writing the word gradient. It's our abbreviation, or an abbreviation for the word slope. These three things in maths all mean the same thing. That's red, gradient, gradient, or slope, slope, slope. M stands for the gradient or the slope. And it's how y changes compared to x. And y is your rise. X is your horizontal distance, which is your run. It's a fancy way of saying it's the rise over the run, which we did last class. So let's get into it. Here's our first example. So these will be word questions and we're going to have to graph things. Water's poured into an empty tank at a constant rate. It takes 4 hours to fill it with 8,000 litres. So what's the rate at which the water is poured into the tank? Well, we've got to draw a diagram first to figure it out, or we could think about it. 8,000 litres goes into the tank in 4 hours. So how many litres would go in 1 hour? If I divide that by 4 and that by 4, that's the same as saying 2,000 litres go into the tank in 1 hour. That's our rate. The rate is another fancy word for the gradient or the slope. Okay, so let's draw a graph. Well, we've got our axes already marked out. Our time axis is always going to be the horizontal axis. So we've got our time in hours. Every 2 squares represents an hour, which means 1 square would be half an hour. There's 1, 1.5 hours, 2, 2.5 hours, 3 hours, so on. And our vertical axis is going up in 1,000 litre lots. Now, it says here to draw a graph going between time of 0 and 4 hours. Well, I've got 0 hours here, 4 hours here. How many litres of water are in the tank at 0 hours? Well, we know it was empty originally, so it'd be 0 litres in originally. So I can put 0 litres in. Now, how many litres go in the tank after 1 hour? Well, 2,000 litres go in every hour, so after 1 hour there'll be 2,000 litres in the tank. Another 2,000 litres goes in this hour, so 2,000 and another 2,000 gives me 4,000. There's 2,000 litres going in every hour. Another 2,000, another 2,000. So there's my value. Now it says to draw a graph. I could have actually got away with just using those values. It doesn't say I have to put the values in between, but it's really useful to know how to find them. So I know that 0, 0, because there's no water in the tank initially. So on here, I could have gone said 4 hours, 8,000 litres, 4 hours, 8,000 litres, put a dot there and just joined them. But if I put my other dots in and join them, I get the same line. So it's important that I can generate the line. You can get away with just using the first and the last value and then joining them, and you'll get your line. Part C says to find the gradient. Well, remember I said when we were finding the gradient, it's the rise over the run, and the rise over the run is best chosen when you choose 2 points close to each other. Well, I'm going to choose these points. That'd be the easiest ones. So when I do this, what's the rise? Well, it's not 2 because there's 2 squares. That square represents going up 1,000. The second square represents going up 2,000. The rise is 2,000. What's the run? Well, that square's half an hour. That square's another half hour. The 2 squares represents 1 hour. So the rise over the run is going uphill, so it's positive 2,000 over 1, which is 2,000, which I knew anyhow because the rate is also the gradient. Now we need to find a rule for our volume. Well, remember, we said earlier the rules will be in the form y equals mx. Well, I don't have a y-axis. What's my y-axis here? It's a volume axis. I don't have an x-axis. My x-axis is dealing with time. So instead of using a y and an x, I'm going to be using a volume equals m multiplied by time. And m is my gradient. So when I put all of that together, I get the volume equals 2,000 times t. And that's the rule for this particular example for the water being poured into an empty tank. Part D says, use the rule to find the volume of water after 1.5 hours. Well, there's our rule. So that's going to become volume equals 2,000 times 1.5 because time is now 1.5 hours. Put that into your calculator. After 1.5 hours, you'll have 3,000 litres. And let's look at our graph. Come across to 1.5 hours. We go up to the line. Now we go back across, and it's at 3,000 litres. So we could have read the answer off from our graph, but it says to use the rule, which means you'd have to write the rule, show the working, and the answer, not just look at the answer from the graph. Now, if I wanted to fill my tank up to 5,000 litres, let's look at 5,000 litres, go across, drop straight down. I can see the answer is going to be 2.5 hours or 2.5 hours, but it says to use the rule. If I use the rule, the volume is 5,000, so I get 5,000 as 2,000 t. Divide both sides by 2,000. 5,000 over 2,000 is 2.5, so it takes 2.5 hours to fill the tank to 5,000 litres. Time to do some questions. Enjoy the magnificent experience that is otherwise known as maths.